Hi everyone, this video is part 7 of data visualization. Let's see the agenda of today's lecture. So today we will learn about two types of charts, and these are volume and density plot. We will learn about them by reading some theory and doing some practical work. So let's get started. So what is actually a volume plot? Comparing various data distributions is possible with volume graphs. Ordinary density curve makes it challenging to compare more than a few of the distributions since the lines visually clash. Since many distributions are compared side by side in a volume plot, it's simpler to do so. A kernel density estimate that has been mirror imaged creates a symmetrical shape known as a volume plot. They also typically have thin box plots overlaid with a white dot at the median. So, how to make a volume plot? In order to compare estimates of the densities of several groups, you should create a volume plot and use geom volume. The syntax for it is as below. First of all, use the ggplot function, pass the data frame and the variables in the aesthetic function, and then use the geom volume as your geom function. Now let's move to RStudio to see how it works. Well, first of all, I will say library, and here I will load the package of ggplot2. All right, and here I have a dataset of diamonds. Let's read it. All right. So I will create a variable of volume plot here. And inside this variable, I will use the function of ggplot. And here I will pass the data frame diamonds. And then in the aesthetic function, I will say take the cut on x-axis and price on y-axis. And outside the ggplot function, I will say geom volume. All right, here let's use the function of volume plot. Let's run it. So you can see pretty volume plots here. And the place from where the width is too much, it means that there is a high concentration of observations or values. You can see that there is a low concentration at this point in good, and in the fair cut, the concentration started getting low from this point towards upwards here. So this is how one can create a volume plot. Now, what if one want to flip this volume plot? They will just simply say volume plot plus code flip. All right, so you can see that the orientation has been changed of your volume plot. Now, what if someone also wants to see the points in their volume plots? So I will say volume plot plus geom jitter. All right, and here I will say height equals to 0 and width equals to 0.1. Let's run it. Well, since you know that you have a lot of observations in the dataset, so it's not a good thing to use this geom jitter here. However, if you have a variable with few observations, then yes, you can use it. Anyway, let's move on. Let's say if someone wants to see the changes in the width of their volume plot, so they will just simply say in geom volume that, for instance, I'm going to say scale equals to count. It will make the width of the volume plot proportional to the sample size. You can see the widths according to the sample size. What if someone say scale equals to width then it will make the width 1 for each of the volume plots. One can also do something like, let's say, while in plot 4, and rather than saying scale equals to width, one can say it just equals to 0.5. So this will give us a closer look at the density of the violin plots. Now you can see much difference in your violins. Now let's make our violin plot look more beautiful. I will pass the parameter in the aesthetic function. I will say fill equals to, and for instance, I fill them according to the color variable. All right, that's great. So you can see the violin plots in each of the gets according to their colors. If I want to see the quantiles for each of the violin plots, I will say here in this geom violin function, draw quantiles, which will be C 0.25, 0.75, and before 0.75, let's say 0.50. All right, so this will make 3 quantiles. So here is the median. This is the first quartile, this is the third quartile, and you can see quantiles in each of the violin plots. Now let's get back to slides. Next, we have density plot. So what is actually a density plot? Although the one-dimensional density estimate produced by state density or geom density is analogous to the two-dimensional kernel density estimate, it needs to be viewed in a different way. It's possible to utilize tiles and map the density estimator to the fill color or the transparency of the tiles, in addition to the default usage of contour lines. So the question is that how to make a density plot. Stat density 2D estimates the density of a 2D kernel using the data. We will first plot the data points and the density contour. The syntax is as follows. Just use the ggplot function, pass the data frame and some parameters, and then you can use the stat density 2D function or geoms density function. Now let's do some practical work. All right. So here, first of all, I will say density plot. And inside this variable, I will first of all use the ggplot function. And here I will pass the diamonds dataset and then aesthetic function. And inside the aesthetic function, I will pass the variable of caret for x-axis. And here I will use the function of geom density. All right. And let's use some parameters such as fill equals to blue, na dot rm equals to true, and alpha equals to 0.2. All right. And here let's say density plot. And now let's run it. You can see a beautiful density plot here, and most of the density concentration is between 0 and 1 carat. And as the carat size increase, there is a little density in these carats in our data set. Well, you can make the same density plot look more interesting by saying, let's say density plot 2, and here, before the geom density, you can say something like geom histogram, and inside the geom histogram, I say fill equals to corn silk and size equals to 0.2. And from geom density function. I will remove everything. And here I will say that take density on y-axis and color equals to gray 60. All right. Let's run it. So you can also see a histogram and a density plot as well. Now let's move forward. I want to involve one more variable inside my density plot. And I say that, and inside the aesthetic function, I say color equals to and cut. And I keep my geom density function empty. Let's run it. Now you can see the density of carrot according to different cuts. If you want to make it more visible for yourself, then you can say something like density plot for, and with the color function, you can pass one more parameter of, let's say, fill equals to cut. And this time, let's note the difference. So you can see here that the density of ideal cut in the carrot between 0 to 1.5 is the highest. And then you have different densities according to cut in the carrot. The good thing is that one can also make these plots stacked over one another. So I will pass the parameter of position, and inside that I say position equals to stack, and now let's run it. You can see that the density plots are now stacked on top of one another. Let's see if we can use it with facet wrap function or not. I say density plot 5 plus facet wrap, and I pass the cut variable. You can see a beautiful density plot according to different cuts. This is the density plot for fair, good, very good, and so on. Now let's get back to slides. So this is the end of today's lecture. I have designed some homework for you. Here is the link of the dataset, and here are some tasks for you, such as making a violin plot. You also have to make a density plot. Then write down the insights you have found after making plots. Now good luck, see you next time.